of AICTE, ATAL sponsored faculty development program. The All India Council for Technical Education, through its Training and Learning Academy, has been a strong pillar in enhancing the quality of technical education across the nation. The ATAL Academy continuously supports faculty members by sponsoring faculty development programs, workshops, and training initiatives that focuses on emerging areas of science, engineering, and technology. We are deeply grateful to AICT ATAL for their generous sponsorship and constant engagement, which has made this academic initiative both possible and positive and impactful. Today's program is a valuable platform for knowledge sharing, personal growth, and meaningful interaction, aligning perfectly with ATAL's vision of fostering excellence in teaching, research, and innovation. On this special occasion, it's my proud privilege to extend a very warm and a respectful welcome to our distinguished guest of the day, Mr. Bala Manikandan, AR, Research and Development Engineer, Power Labs, Chennai. Sir, your rich experience in research and development, coupled with your expertise in power and instrumentation field, will undoubtedly provide deep insights and practical perspectives to all the participants gathered here today. We are truly honored by your gracious presence and thank you for sparing your valuable time with us. I will also extend a cordial welcome to all dignitaries on the dais, respected resource persons, faculty members, and enthusiastic participants who have joined us for this program. Your presence adds a great value and significance to today's event. With this, I welcome once again you all for this engaging and insightful session.
At this moment, I kindly invite Dr. N. Mahadevi Ma'am, Associate Professor Tripoli, to formally introduce our distinguished guest for this session. May I request Ma'am to please take.
Good afternoon, respected dignitaries, faculty members, and dear participants. It is my great pleasure to honor our chief guest today's afternoon session, Dr. Bala Manikandan sir, AR, R&D Engineer, Power Lab Instruments. We are privileged to have Mr. Bala Manikandan sir, AR, and R&D Engineer at Power Lab Instruments with us today. He is a highly skilled professional with a strong specialization in EV domain. He has completed his Bachelor of Engineering in MPE, and since then he has been actively involved in the research, development, and testing of advanced lab solutions. Mr. Bala Manikandan sir possesses extensive technical expertise in BMS, EV charger, discharger, tester systems, bidirectional power supplies, power electronics, battery technologies, EV motors, and controllers. His work is deeply focused on designing, validating industry-oriented lab kits and support both academic learning and advanced research. In addition to his technical contributions, he regularly conducts hands-on training programs for the students and faculty members. He also works closely with the PhD research scholars, assisting them in the experimental setup, design, validation, and systematic execution of their research work. His efforts strongly bridge the gap between the academic research and the real-world EV applications with a clear emphasis on practical learning and innovation. We are confident that today's FDP will highly insightful and enriching under his guidance, especially in understanding the practical aspects of EV BMS. On behalf of the organizing committee, I warmly welcome Mr. Bala Manikandan sir here and thank him for being with us today. Now the stage is yours, sir.
back to EV, just clarifying about the battery management system. So this session we can learn something about what are the things that are happening in the BMS and what are the protocols that are working in the BMS database and what are the types of BMSs. So which we need to discuss in future or else in already like this. And what is the main role that plays in the AI playing the role of BMS database. So that's what we are going to see in this session. So first of all, I just thank management as well as faculty, especially Kamal sir, for giving this great opportunity to participate in this activity. Due to some other reasons, our team is not able to participate in this. On behalf of this participant in this. So hope this session will be kind of so I'm just starting the slides. So before I start, I'll just indicate some other features what we have to see look after this BMS structure. So basically nowadays most of the persons are using the EVs. So what are the types of EVs? Why we need to use EV? Like I say, those sessions are coming in the February. So mainly the EVs is categorized into 4 types. That is batteries, controllers, motors, and then ADAS, which is different types of sensors which we are using as EV protocols to monitor the driver as well as some other protocols like this. So I'm just taking the first part, like this batteries. The main like this the heart of the EVs are the batteries. So without battery, it's not possible to run the EV. That is the main component which is used in the EVs. So to protect the batteries, just avoid the thermal runaway and to how long we can run. So the health of the battery, charge of the battery, like this, you can check each and every notification. So for the purposes, we are using the BMS. So the BMS is mainly battery management system. So in this session, we can learn about something else about the battery management system. What are the protocols that we are using to battery management sets, and including the voltage, current, SOC, and SOX like this. I do have some BMS in my slide. So let me show the BMS how it works and what are the things that we have behind the BMS, and especially in the brains behind it. That is the main component. That is not only for the engineers or something research sites that do not have ready. We are talking about the technologies and the control units which are behind the EV sites. Because the first one is starting from the battery management side and vehicle control units. There are different types of control units having the EV sites. So vehicle control unit, motor control unit, controller control unit, like this having different sessions. So one by one in the control unit we are having the major component is the BMS. So that is I'm just starting the session. So thank you for this opportunity. In this article we can see about the battery management system right behind the EV technologies and the challenges without BMS and with BMS. And then types of balancing. That is, we are having 2 types of BMSs, that is active and passive. So how it works, like this we can see. And about the future EV. So while using the artificial intelligence, the BMS, what are the steps and protocols that will be added, and in future what will happen, that is we can see. So mainly I am just coming from Power Investments, you all know about that. So Power Investments is the company, this is from the since 2009 starting. So we have some more and more R&D engineers as well as production, installation and all. The main focus of our company is to develop the kits, R&D kits, right? So to deliver the colleges, universities, etc. So these are our products. We are having different types of laboratory products like this power electronics lab, power systems lab, EV lab, and renewable energy. So like these labs we are focusing. So I'm just giving some short bio introduction to EV. So nowadays, most of the vehicles are, we can see in the college campus, most of them we are in the EV, 2-wheelers, scooters, bikes, 3-wheelers, even though in trucks, buses also nowadays in EV, in NPC also there are so many buses in EV. So what is the main cause of body emissions due to the pollution as well as the fuel efficiency? We are just talking about that. We are just focusing on the EV sides. So EV has no any other that is green. So it won't get any smokes and all. So it will be somewhat protected. So only we are just focusing on EV. And the EVs also we are having different control systems like already I have mentioned. So we are just in this system we are just mainly focusing on BMS, battery management system. Why we need battery management system means without battery management system the battery cannot be protected. That is one type of control unit which we are focusing on the battery. By the side voltage, current, SOC, HOS, and also we have different types of temperature sensors in the battery. So that means to protect the battery from the thermal runaway, we need to use some thermal temperature sensors, voltage sensors, current sensors to protect these batteries. So these are the combination components which they are rejected from the years. They are actually the mainly the views are from the Chinese side. So Chinese are Japan, others from Korea, likewise only values. So not majorly in India they are started now only they are starting to produce and about manufacturing for the BMS. Till the process is going on. Due to the cost only we are just we are buying from the China products. So this is also coming from communication protocols. Again, say UART. So we need to get the information from the BMS. So we are using a UART. The UART means Bluetooth. So we are having different types of mobile applications as well as the PC software to get the communication by RS coded communication or else CAT protocols. So banks behind EV technology. We are having somewhat the banks behind the EV technology. That means these things are the core electric and then communication protocols, software intelligence, and the intelligence integration to the technology. So the banks means mostly we are using a battery management system, and then motor controller, and then VCU, that is vehicle control unit, and then powertrain control unit, and charging systems, and also last one is thermal management system. So these categories are we are using. So mainly in BMS what we have used and what are the protocols that we. So we can get the software intelligence by through AI or embedded systems we are using. So next communication protocols like CAN, link, and then also define those communication protocols can be to provide those data that is those communication. And also the last one is integration. So just integration into the IoT space. So if we are using a router or else anything else like Wi-Fi communication, so we can get the data through the Wi-Fi module. So from the data we can monitor our vehicle, even though if my vehicle is running in the Delhi or somewhere area in the state or else in the country. So I can monitor from here. So how many percentage of the SOC is running. So these communications I can get from the only the tool called PMS. These are the main core components that we are using in EV. That is the first one is battery and motor and VCU, that inverter. Inverter means nothing. If we are using any regenerative braking in the systems, not and in every EV there is an regenerative braking system. So once we are applying the braking, there will be some vacuum to be produced. So due to the vacuum, we will be set to the inverter. We can get the we can charge the battery by using this vacuum. This one is for running. Actually, mainly we are placing the batteries in the roof of the cars. Why? Because of the space and then also the consideration of the somewhat we need this of the spaces, and if anything costs the transaction, we can avoid. So VCU. VCU means vehicle control unit. Vehicle control unit mainly focuses on the can that is control area network. So the VCU only we are just handling the battery pack, motor, and then other signals like base controllers and what are the sensors we are using. Mainly we are connecting it to the VCU only. The CAN protocols, so we can get the communication data from the CAN protocols. Then actually the VCU may be called as the octopus framework. Likewise, it's having different types of communication, battery management, thermal management, and regenerative braking, lighting control, power steering, air conditioning. Likewise, these are the some which I have known. So you will have different types of controls which will be the control in the simpler machine. So these are the main characteristics of the EV. They are using the transmission motor and power distribution unit, and the inverter we have, and also they are having some liquid control unit, BMS, onboard charger, outboard charger, and what about the traction battery we are using. So next to that, the DC-DC converter. Why we are using the DC-DC converter means we require some for the headlight indicator we need to use full load battery, full load supply. So for only we are using the DC-DC converters. Now I'm just returning to the battery side. So the battery means it is one of the source. So without battery, it is not possible to run the EV vehicle. So this why mainly in batteries, EVs we are using the lithium-ion batteries. Instead of using the lead-acid batteries, we are using the lithium-ion batteries. Why means lead-acid batteries have no protection in that. So in case of what we are considering the lithium-ion, we will have some protection, that is the BMS. So why they are not using anything in lead-acid batteries? Means lead-acid batteries have some acids, so it is not possible to predict the cell voltages at all. In case of targeting to the lithium-ion, means there will be a single cell batteries, and also it will be in the solid state. So it is easy to carry, and also it is easy to select the sensors. We can place the barriers, and we can collect the data from the each cell voltages. So only we are mainly using lithium-ion batteries in EVs. Battery management system. So battery management system means there are functions. Some functions of BMS are available. So like this, the main function is to protect the battery. That is the only main function to what the BMS code. So we are having two stages, like a state of charge and also state of health. So we need to consider the state of charge. Like this, we are using mobile phones. Mobile phone also we are having same lithium-ion batteries. So same lithium-ion batteries means we are plugging in the charge while it decreases below the 20% of the water. So same thing we are doing in the BMS battery, real battery also. So once the BMS battery being below, the electricity below is 20% charge, and after reaching 100% it will automatically shut off. So that is called the adaptive charging. So it depends. The adaptive charging it depends upon the temperature. It will be based on the temperature only. So once the temperature gets increases, the charging current will be somewhat decreased. So that's the thing we are doing. So next to that. So the state of wells depends upon the cycles. If we are using the usage of the batteries, once we are starting the batteries from the side, regularly we are charging and discharging is normally EV battery has 3,000 to 5,000 cycles only. So once we are charging up to 100% and we are using 0% means that is one cycle. So again we are charging and then using is it will the cycles counting will be started. So from the starting counting of cycles, the battery health will be somewhat reduced. Often we are charging, often we are using the battery means it will the health of the battery will be somewhat reduced. So these protocols I need to measure means I give some BMS lecture. So to get those information from the battery, so only it will be reliable to the run my vehicle in the proper manner. So if anything crosses, it will be for example, if any wires are shorter, if one cell is decreased, then one cell is in condition means it is not possible to run the battery in safe manner. So we need some production parameters like this. If we are in build of the BMS system means it will take us of the charging and recharging characteristics. Once we are charging the battery similar times, for example, I am just using 60 volt battery 80 mAh capacity. So I am just charging the battery in 1C, that means 80 amps. So if I am just charging the battery in 80 amps means the battery will be in stable condition. If I am just charging the battery in 36 amps means then that becomes into the 2C. So once I am repeating the process, I am just charging into 2C and again recharging into 2C. What happens to my battery means there will be temperature will be rising. So once the temperature rises means what will happen? So there will be some cause of thermal. So if anything due to the pollutions and the bursting and all happening only temperature. So and also the short circuits. So once we are using the batteries, if anything gets shorted, means the suddenly that what happens is the way some machine will be put in the battery. So it depends upon the it will be may cost to the redundant. So that's what we are concentrating on the SOC as well as the source of the battery. For passive purposes, we are using two types. One is for passive and active. So once we are using into the active means the active balancing will depends upon the if my one cell is in 100%. Sorry. For example, my nominal voltage of the battery is in 3.6 voltage. So in case my battery is on charging, my cell enters into the my version enters into the 3.7, but my second cell is in 3.2, means that is called imbalancing. To balance this, only we are using the active cell or passive cell balancing. So, what is the main difference between the passive and active means? Once the battery is in 3.2 volt and another cell voltage is in 3.8, means it gives imbalance. So, for those communications only, we are using some resistors inside. So, it will reduce the battery voltage from the higher voltage to the it will give the supply to the lower voltage. That is one cause. In other case, what happens means it will directly reduce the higher voltage of the cell to the lower voltage directly. So that's happening in the passive cell balancing. So mainly in EVs, what they are using is they are using the passive cell balancing only because of the balancing state, and it won't affect our running routine cycle. That means some voltage of the battery. That's what we are using in the EVs. We are using mainly we are using passive balancing. And the control will basically indicates the charging and discharging. While charging, we need to charge this kind of amount of battery, voltage to the battery, and only they are depending upon the control sector. And then the current, depending upon the cell voltages, and each cell currents have to be displayed in the register. Next. So mainly we can concentrate the vehicle range. If I am starting my vehicle from the scratch, like I say, the battery voltage SOC is depends upon the 80%. So how much I can travel? That is range. You can calculate the range by using the usage before usage and after usage, and you can calculate the range how much kilometer we are running. So this much kilometer once we are started the vehicle, is how long we can travel. Where are the charging stations that are located in the surrounding areas like this. So this is the cell balance. As already we have talked about the cell balance, that is active and passive. So next is SOH, SOC, and then SOP. That SOP means nothing, the state of power. Depending upon the state of power which we have already used and we are going to use. The next is production setup. So mainly the BMS, what happens is there are several production setups. Initially starting from the some voltage. Like this, the maximum voltage and minimum voltage, and maximum current, minimum current, and cell voltages also, maximum cell voltage and minimum cell voltage, and depends upon the SOC also. If I need to stop my vehicle, once the SOC becomes 20%, I can develop my own program. I can also enable I can also implement in the BMS. So we are using the microcontroller units only. It is possible to implement easily. So once I need to stop my vehicle, once it becomes below 40%, it is possible to stop the vehicle. And also, by using the BMS, we can give supplies to the batteries in different manners. Like we are using the AC chargers or DC chargers, and also we are using the solar charging or wind charging. While using the bidirectional power supply, we can give the charges. We can also implement by using the bidirectional power supplies. So like this, we are giving the DC power supply to the battery. So we can set this much current I need to be charged, this much amount of the voltage I need to be charged. So and also depending upon the SOC also. So I need to charge my battery up to 80% only. So it is possible to charge up to 80%. You can set whatever the equipment we need to set, we can also set in the BMS. So next one is terminal management. So we need to avoid the terminal management center. So we are using different types of sensors in the batteries also. So mainly that is NTC, that is negative temperature coefficient sensors we are using. So once the battery becomes negative sequence temperature also, it is possible to run the vehicle. If it is in north side or some other countries, there will be a more cold. So that time the temperature will be below 10 degree or 15 degree like that. So the batteries can be operated in that similar temperature itself also. So for the purposes, the team also develops us to whether we can run the vehicle or not. Like this, we can get the communications to the drone, mobile or somewhere else by then alarm. And then the charging and recharging. So normally we all know about the charging and recharging. So once we are starting the charging and the charging means, so this much of amount of charge we can charge and this much of voltage we can charge, and according to the voltage and the current. So once I am just charging a battery in this current means how long it will take to charge. It is 1C charging, 5C charging, 2C charging, 3C charging, like this we can add on. So the mainly the charging will be focusing on the voltage and the current. These are the different types of cells we are using in the BMS batteries. So mainly there will be whole cell and cylindrical cells, prismatic cells, and the last we are using the module as well as the battery pack. The modules are used in the normally in the 3-wheelers or 4-wheelers like this, and the battery pack will be used in the buses and the heavy load vehicles like the trucks, and also in the cars. Cars also they are using the battery pack. So what will be different means the cylindrical cells means it will have some minimum cell area capacity only. So like I said, it will have up to 10 AX capacity only. If more we are going to the power cell or prismatic cells means we can go up to 200 AX or else 100 AX cells. So the only connect to the space and using this type of heavy load trucks we are using this type of power cells or prismatic cells. So we need to verify whether our battery is in good condition or bad condition. So for checking these purposes, we are using the recharger kits. So charging and recharger kits is available. So we can just plug in the charger and we can charge the battery. Likewise, in the starting from the point 2C to 2C. So once the battery is in 30 AH means I can give the 30 amps current to charge my battery depending upon the voltage. So if I am using 60 volt means the charging voltage will be up to 67.5. So I can set the 67.5 and I can also set the 30 amps charging. So I can predict the values, how much current is getting and how much voltage is getting. So I can compare from the hours and minutes also. So thermal management system. To avoid these thermal management systems, we are using the temperature sensor in the BMS. It will product.
What is the cost of the testing? Previous.
This one, sir. So it depends upon the voltage and the current. So if you are using any temperature,
How long do you can store the data?
so from starting to ending. So once you are
For day-wise or
for day-wise also for the period also. If you are using for the 3 hours sessions, you can plan the battery and you can show that. You are talking about the BMS or then this tester. Yeah, this tester. Once you connect the battery, if you are charging and recharging or making it, you can get the data.
what is the minimum capacity? What is the rate of minimum capacity tester?
This one, sir. Actually, this one this is 20 amps, 20 amps. And you can use both the lead-acid batteries as well as lithium-ion batteries. Starting from 9 volt to 98 volt.
Cost of the battery.
Cost I don't know about the cost. To provide our batteries only, they are using the temperature sensors. So we can monitor the temperature. If anything happens at the battery, it will suddenly cut off the output voltage. So only then we are using the temperature sensors in the battery. The challenges without BMS means if we are not using any BMS, we are simply using the battery. What happens is when charging and recharging, there will be an imbalancing. Likewise, there are only imbalance in the cell charging. So once the cells, first cell will be in the 3.2, second cell will be 3.4, and third cell will be in 3.6. What happens means due to the series and parallel combination, it will affect our battery, and we can also it will also affect our some voltage also. So once we are running, we can analyze the gap between the voltage, whatever voltage we are supplying to the controller or something. We can analyze the using the imbalance of the voltage. So to protect all those things, we are using the BMS. The hardware considerations. We are just considering the sensing there are three sensors in the BMS. One for sensing the voltage, and one for sensing the current, and the last one is for sensing the temperature. So we are just sensing these voltage, current, temperature to protect our battery. We are also having some systems. Like we said, it depends upon the voltage means what are the how much current we can give, higher and lower. So the maximum minimum voltages, and then maximum the minimum current, and maximum minimum temperature level. We can also select. We can also set. Once we are in the summer season means the maximum the outdoor the degree Celsius will be more than 25 or 28. So we can set up to 40 degrees Celsius. For these type of temperatures, the battery can be active. So like this can be state of monitoring. The state of monitoring means we need to monitor our battery regularly when we are running the vehicle, or else we are going to start the vehicle. So we need to charge and discharge. We need to monitor our vehicle regularly. So once we are starting our vehicle, what are the things we need to monitor? We need to check about the initially we need to check about the some voltage, and is there any alarm display? Like the voltage level is low, temperature sensor is higher. Likewise, if anything is listed in the alarm management, we need to restore first initially. So after that, the real battery voltage is what we are using. So normally the voltage will be in the balance sequence, and also we can calculate the range values. So now I'm just going to travel 20 km from the battery SOC is 40%. So whether I can travel to the 20 km or not. Likewise, we can also calculate it by using calculations also, or else they is helping us to protect our range. So this much kilometer we can also set the range. So this much kilometer I need to run. Whether it is possible in this SOC, like this we can also get. So the estimation means the state of estimation means the state of the state of health. So SOC and SOP. So mainly we are focusing on the SOC and SOP. If SOC is below 50% or 60%, we need to charge the battery. So if it is crossing more than 100, means automatically the charge will automatically cut off. Don't charge after 100% of the. Then SOP means if once the battery becomes below 80% means definitely we need to change the battery, otherwise we need to change the cells. Why? Because means the battery is the health of the battery is reduced. So we can travel, we can predict the range also. How much long I can travel, we can, it is not possible to predict the range. Once it below the so that's below I think below 80% or 70% it is not possible to predict the battery range. The production mechanisms what we are using means for the charging and over discharging only we are using the production. So once we are charging the battery up to 100%, so I need to stop with my battery. Someone is saying it's not we should not often we should not charge up to 100%. I have to stop within the 95% discharge means it is possible to stop. So and also the over discharging. If already my battery I have discharging up to 60%, again I am just discharging to 40%, and again I am discharging to 20%. What happens means the temperature will be rise in the battery, and also we can feel somewhat the battery SOC is reducing, and also the health of the battery is also reducing. So suddenly it may collapse, and we can get some wrong values in the data. So to stop this, we need to use some frequent resistors, and also we are using some retail braking. So once we are applying the brakes, we need to just use some space to charge the battery. So once we are charging the are acting in the same pressure, we can get the batteries in the frequent conditions. So already we have talked about the active and passive sequences. So once we are just concentrating on the active field balance sequence, nowadays in buses and trucks they are using the active field balancing. In passive depends upon the only the voltage of the voltage. It will balance the cell, but it won't disturb the high voltage. So once the cell voltage is more than 3.7 voltage, it will the resistors which are inbuilt in the cell, it will reduce the voltage from the 3.8 cell and it will be passed to the 3.5 volt or 3.4 volt cells. So while balancing, what happens means the balance will happen only when we are charging the battery. So once we are getting somewhat charges and somewhat pressures in the current in the additive balancing, passive balancing will depends upon the cell balancing.
அவருக்கு அந்த பிரேக் கொடுக்க சொல்லுவார். அதுதான் 240
So back at the
245 ஸ்டார்ட் பண்ணி 3க்கு முடியுமா? இல்லை
to
சார்.
resume the session from
So why we need the cyber security means due to the regulation as well as the EVs also growing. So they are normally if you want to having only one EV, one car. Nowadays you can see there are more than one, like this 3 or 4 like this. So the main brain is our BMS, sorry, battery. So we use battery by using the BMS. So why we are going to require the cyber security means if anything hacked. So due to any we are having some Wi-Fi modules, communication protocols like this. So if anything hacked means they can stop the vehicle easily. So once we just upload anything means the vehicle will be stopped. It is not possible to run in the night times. If we are stuck in some between times, it will so only we require cyber security in the BMS. So normally not only in BMS, all over to product our EV vehicle we require the cyber security. So the monitoring and all already happening. Then the accuracy, we need some accuracy. So like this millivolt and milliamps. If actually if we are running the motor means, then normally it can take up to depends upon the motor range. So how we are applying the actuator and also depending upon the regular areas, it may have some motor current. So there will be some minimum current will be taken from the battery due to the key ignition or somewhere else to display something. So those all comes in the milliamps. So we need to also monitor the milliamps also. So we need some accuracy. So if operator is taking 0.5 amps, that means 0.5 milliamps, 500 milliamps means we need to record this. Somewhat okay, that is only 500 milliamps. It is nothing will be happen like this. Means after 1 or 2 hours, our battery or SOC will be also reduced. So these are the accuracy we need to see in the batteries. So estimation. The estimation calculation will be somewhat vary due to the charging and discharging characteristics that are happening in the battery, due to the ignition, we are starting the battery and moving the vehicle towards or backwards. There will be some estimation may be very depending upon the somewhat we are running in the vehicle 1 kilometer this range. Often suddenly it is going to 70% or 60% means we can think that. So why this are happening is if we are having the distance covered by the vehicle to the 1 kilometer range. So suddenly it drops 10% of SOC means we can calculate the rate due to the imbalancing or else somewhat the current varies in the battery may be affect the estimation of the SOC. So the risks already have seen. If there is any terminal unavailability, that will be causing this. So we need to concentrate on the temperature as well as the SOC of the batteries. So So how long we are traveling, and if we keep on traveling for a long range of 200 kilometers, we need to give some rest to the battery. So that will be more benefit. So only in most of the batteries they are using coolant fans to cool the BMS as well as the batteries also. The regulatory standards, still our scientists are the research persons are the researching in the side to develop the BMS and how to stop these activities. And normally there will be an own e-waste due to the imbalance. Something may happens and the BMS it will automatically cut off, and then BMS is waste off. So there are the regulatory guidelines. So it may be cause more if you are extending the research also, it may be cause some defects in the BMS. And AI, so due to AI, artificial intelligence, so we can monitor the battery by using the somewhat regulation protocols, IoT based somewhat else. So once we are traveling in the range, we can automatically detect, and if anything happening in the battery, if we want this kind of from the vehicle means we can do we can monitor and do the alarm list with our mobile phones or something. So once we just park the car and we are just putting the charging in charging center, and we just go for the shopping of models. If charger full means it will send the message to our mobile phone that will alert us. So charge the full day. So we can detect time to for shopping and that. Why we are mostly using this type of BMS, solid state batteries. The solid state batteries will be more comfortable for the travel purposes, which are using the EV sets. So only the batteries, the BMS are mostly used with the solid state batteries. And wireless battery management system. That is the IoT, remote controlling, Wi-Fi based modules. So we need to monitor our battery. Everywhere if we are running the vehicles from the long distance or short distance, we need to monitor our batteries. So for that purpose only we require the wireless monitoring systems. Then recycling. Already I have informed that. So if we are using the BMS for a long time process, if anything detects or any case having any short circuits or things, we can recycle the batteries by changing the resistors or something else. And also it is possible to change the current sensors which we are using. And if we need to upload the software side, we need to change the performance. It is possible to change. The future will be whatever things we are just facing in the AI side. It may be monitor the battery, and in future there won't be any effect from the battery sides like the overheating, thermal runaways, and then charging, discharging, balancing circuits. We can monitor easily. So that's all about the session. So again, I'm just listing some different types of BMS what we are using in the TVs nowadays. Actually, I have listed two types of batteries, BMS. Because this is active passive BMS and this is active BMS. So these are the main differences between the active and passive balancing. So mainly the BMS will focus on the battery negative point only. It takes only the battery negative point, and this will be the output. So if anything happens in the battery, like as the voltage increases, voltage decreases, SOC increases, decreases, means it will cut off this negative point only. This is from the battery and this is from the output side. And we are having these are the temperature sensors which we are using in the batteries. So this is negative temperature coefficient temperature sensors which will detect the cell voltages. So this only will be detect. And we are having totally there will be 4 temperature sensors in the battery. It will be placed in the 2 will be in the outside and 2 will be in the other side. So on the next this is UART. The UART means nothing Bluetooth connection. So we need to monitor our battery by using the Bluetooth. So we are having the software server. So here I am just listing the DALI BMS. So after getting some research on site, we choose DALI and another one is JBD. So those 2 BMS only we are preparing and we are just supplying to the customers, I guess your universities and all. So for to get data means we are using this type of. You can get the CAN protocol as well as RS communication. So from this you can get the every second data. The any fault in the BMS, you will alert this. Also we are having a software also. Let me show you. And then this is the buzzer. If anything happens like this, the temperature is more than high. We need to monitor maximum temperature. If maximum 7 days happens, it will automatically cut off and detect by using the buzzer. There will be an LED buzzer also on there. And the same protocols we have used here also. But the only thing is, little bit each cell voltages will be in taken this. So it will be sensors. It need to be monitored each cell voltages. So each cell positive will be taken from this. So from the each series point. So for example, we are using the 60-volt battery in 19-inch piece. When the nominal voltage of there are in EV we are using two different types of batteries, lithium-ion batteries. One is lithium ferrophosphate LFP and another one is NMC, nickel magnet copper. So these two only we are using. The cost wise, we are comparing to these means the NMC will be a little bit costlier than the LFP. Why we are using the NMC and the LFP means the LFP synthesis may be somewhat vary and then the NMC is somewhat little. So only the NMC is majorly used in the EV vehicles due to its cost. And also the safety and all, safety and performance will be more or less both are same. The nominal voltage of the NMC will be 3.2, the nominal voltage, and then NMC will be 3.6. And this will be the active visual balancing BMS. Here the only thing, the connections are the same one thing, but the only thing, it also gets the positive side of the BMS also, the battery also. So here we are giving the negative side and also this side we need to give the positive side also. Why we need the positive side means it will sense the some voltage also due to the performance we are having in the sensor while charging and discharging the energy. This is JPD BMS. Here the protocols are released. We can see in the on axis also, and it is possible to load our programs here. So there is a port available here. So we can also, if we are doing any protocols, we need to load any programs. It is possible here. We can load also programs. And if we need to edit some requirements like this parameters, production parameters, we need to also it is possible here. So we can also edit it. And the same way, this also taking the negative coefficient. That's one important here. Only the sensing only we are giving the part. Actually, if we are going to DAY means there will be a 19 years or 15 years, 12 years like this. But here up to 24 years they are using the single BMS. So only one BMS up to 24 cells series cells batteries you can use. Only it depends upon the connections. Here they are having some connections here. So due to the connection protocols you can connect the batteries. So if we learn any non-connection means the BMS is not. So that's all. And same thing here also having 485 RL scan communication and also here also the URL is available. Like the mobile app also available, PC communication also available. Next we show the software details. In the software, so in the software you can monitor. This is the multi-purpose. This is the BMS software. So both for active and passive, they are using the same sort of thing. So from this software you can monitor the sub voltage, current, SOC, and then the last one is alarm list. If you are having any alarm list, it will be listed. And cell voltages. So it depends upon the range how much we have calculated in the series parallel combinations. If you are running in the parallel links also, there will be the same frequency. So they will list the single package, the first parallel series combination. So next to that, the battery status you can monitor the maximum voltage, minimum voltage, maximum temperature, minimum temperature, and also the BMS life, remaining capacity. How remaining capacity is calculated means we are having on single cell. So maximum the single we are using only 6 AS cells, or else 10, 20, and then 50, 100. So up to 100 AS only we are using. So they are having more than 100 AS cells also available. We are using up to 100 AS. 100 AS means we are using not cylindrical cells, that is will be prismatic pouch cells. For vouchers also we can use this same BMS. For cylindrical cells also we can use this same BMS. While taking this, how we can calculate the remaining capacity means initially we need to discharge the battery cell fully. So once the battery gets discharged, means it will be in the 0% of the SOC. That means 0 AH. So next, we are just giving the full charge to the cell. We can measure the voltage up to the normal voltage is 3.2 means the maximum voltage will be 3.65. So once it charges up to 3.6 means somewhat after reaching this maximum voltage, there is no possibility to charge the battery cell. So there we can measure that is the maximum capacity of the AH. So by the maximum capacity, you can note that is a when we are making the series of parallel combination, we can analyze that is a 6 AH battery, 12 AH battery, or 18 AH battery, like this you can monitor. And then you can note on after that you can check the battery cell voltage also. If the single cell voltage is 3.3 means you can assume that, and the maximum voltage is 3.6. The 3.3 means that is the 50% of the voltage. You can assume that is the 50%. So like let's say the battery cell is in 6 AH means you can assume that is in, now the condition is in 3 AH like this. So like this only the remaining capacity is configured. And how the SOC is calculated means we know the total capacity of the battery. The total capacity first we initially need to calculate the remaining capacity of the battery divided by total capacity into 100. So that we can get the SOC of the battery. That is state of charge. And here you are noting DAY-1, DAY-2, that is digital input and digital output. If you are having digital input or digital output in the ports means you can assume that we are having these protocols are having used. We use only we are using only one digital input and digital output. So if you are giving any digital input, for example, I am just entering some values by using the software or somewhat else. I need to change in real time means it is possible to change here. So once I am just implementing my ratios, others I am just changing the parameters means suddenly it will cut off the battery. So there will be a second for a second or 2 minutes, 1 minute, the battery will be cut off. So we can note that. So once we are running the vehicle and suddenly we need to change the protocol, that is not possible. So we need to stop the vehicle, then only we need to change these parameters. And also the SOS will be, we can also get the SOS by using the same software. So it will also estimate that after the running the cycles, if you are running after 100 cycles or 500 cycles, if in case any short circuit happen, there is no any short circuit happen means then our battery health will be in the 100%. If anything happens means only the health will be reduced. And the charging SOP and discharging SOP we can say. So I need to charge my battery up to 95% only. So I need to stop from here means it is possible to switch. So I need to discharge the battery up to this percent only. It is possible to switch. And the last we will discuss the battery temperature. How much temperature we are using. Normally we will use 4 temperatures and also 1 MOSFET temperature. That is from the BMS. So BMS have 2 MOSFETs. For charging there will be a separate MOSFET, and for discharging there will be a separate MOSFET. So this is active cell balance. If you are using any active cell BMS, you need to turn on this supplies, but you need to enter the values. What are the values? When it need to be happen, and when it need to be stopped, and what range it needs to be stopped on the peak time, and then the real time current. If we are just charging the battery and we are turning on the active BMS, and we are already the equal. Once it started happening, there will be some reduce in the current. So it will take some current to reduce the voltages. So the things can monitor from the BMS itself. These are the parameter settings which we can also editable, all are editable only. So once we just compare with the password, we can also edit the battery parameters. Later capacity. So you know the rated capacity up to 18 years or 20 years. And then next to that, the cumulative charge and discharge. For example, I am just charging and discharging, I need to set this type of capacity need to be charged and discharged. And and also the cell high voltage, cell low voltage, and some voltage high, some voltage low, recharging current, charging current, all are edited only. You can also edit it also.
We have games in the radio.
Yes.
The owner, we have the rights to.
Right. Yes, you can say that. Yes, sir. So once depending upon the BMS, what we are using the
Software automated by your company.
no, sir. It's a common software that is from the this we are just communicating with the DAY-1. So we have some likes. So they have providing this software, the licenses. There is an somewhat license without license also there is no license available. That is DAY-1. According to our protocol, they are mentioned in the India protocol language, so you can download from the website. But the only thing is, if you are having the license software means it is possible to edit the values. Otherwise, it is not possible to edit the values. We need to enter the passwords there, and need to administration brackets there, and monitoring brackets there different. So we need to give the protocols and then we need to enter the password. So only we use possible. So these are the engineering models. It comes under the control management. So once we are just developing a BMS and we are just teaching it, we need to calculate on this. So how we need to wake up our BMS? We need to key. There is a key for BMS also. If we need to put key in the BMS, to wake up means it is possible to wake up. And like in we are just switching the task means that way there also the key. And also the button type also available. And next to that RS code communication can protocol. And then last one is we just insert the connect the battery to the load, just load anything. That you are just turning on the motor controller, we are just getting the battery output, it will be better. So next to the control switch. If I need only discharging one day, no need to charge my battery, you can switch off the charging switch, and only there will be possible to only for discharging. It is not possible to charge the battery. Like this you can protocol cancel. And then next one is the DAY-1, that is digital output. So I need to get some digital output from the battery BMS, like this communication protocols. If that is not required, it is possible to turn off the digital output also. Here it is not possible to get the range. Only you can get the SOC and SOX parameters, and you can get the some voltage and you can get the temperatures and all. Range means we need to calculate the supply range. That depends upon the motor and then also kilometer watt gas. That is ECU. That is common. So it will the ECU what main thing means it will get fetches the information from the BMS, motor, and then controller also. It will fetches and automatically in ECU only we are just calculating the range. In ECU only there is a range formula. It will fetches the battery BMS and motor torque. What are the loads that we have applied before itself, and the depends upon the tubes also. If there is any slope means there will be some range. So if there is any peak means there will be some range. So that's it. The difference upon the motor also. So here only we can get the SOC and then current what we have. So next to the as already put the fan switch in the BMS. Sorry, BMS also has a fan, and also in motor the battery also there will be a fan for just a cooling purpose. So then heat on means we are having in case of we are having the winter season, there will be a degrees Celsius up to minus 20 TD or something else. We need to give some heat. So it is possible to provide the heat also. So next to the inverter manager as well, we are just how we are getting the communication protocols. So alarm history. Here we can get the alarm history. Once just turning on the ignition means how the alarm history is covered. Where it happened. So it depends upon the service data. If you didn't charge the battery for a long time, so 1 or 2 months, you are just left, and it is not possible to start the car, and also it is not possible to get the output also. So if you are going to service center, you are just giving the battery to service the battery. So they will ask you whether you are charged or recharged. If anything happens in the charging or charge rate means here in the alarm list you can notice all these parameters. That's all about it. The BMS updation, that is in the update mode. If you are having any update in the software, you can do it. So that's all about the BMS session. So from these sessions, you can read the alarm data, and if you need your data, current data for the second semester also, it is possible to store. So these are the alarm list which are already happened in the PMS. So first one is going in low voltage. So once there is a low voltage means it will register here, and where some voltage is 50.5. I have connected 60 volt battery, but the voltage is 50.5. So this will be in the alarm list. So these can be managed from the service center side, or else the protocols are where they are used. These are the parameters which we can get from the data, get from the BMS system. So the first will be the SOC, battery voltage, and the MOSFET is on or off, charging MOSFET, recharging MOSFET is on or off, SOH, and then every single cell voltage as well. So it depends upon the maximum range, minimum range, and then single cell voltages, battery temperature. Actually, this is in Chinese mode. Actually, I don't have that picture here. So this is for example. So it is available in English also. So maximum you can get the values from the MOSFETs only. First is charging MOSFET is on or off, and then some voltage, and then current what we have applied, SOC, SOH, single cell voltages, and then temperatures also. And last one that the comparison between before and after charging and before charging cycles, normal cycles we have that, and then remaining capacity. And once we have started the session, started the vehicle at the how much SOC we have started and how much distance it has traveled, like that we can do. So by using this software. So this is another one type, that is DAY, and this is JPD. So here also we can monitor the same protocols only, but only one thing very unique in parameter settings. Here the capacity configuration is happened by using the voltage, single cell voltages. So in DAY it often sets from the 0% to 100% only. But in JPD means we are just giving the user are entering the values. For example, 100% means we are just entering the value of 4.1. They have entered. For example, only that. So if you need to change anything, any values depending upon the SOC, we need to calculate. So like this, 3.1 is the full voltage, 4.1 is the full voltage, and 3.3 is the 10% voltage. Means we can also calculate. So we can also user can enter the values. So from entering the values, you can calculate the SOC. So that's another method, and it may be very simple proofs. So we are in DAY they are using proofs. Here they are using the user interface. There's only one difference between DAY and the and also calculation is here. So can calculate the inner resistance of the cells. So in DAY it is not possible to calculate the cells resistance, but here you can calculate the cells resistance also. And also NTC data. So if you are just giving the NTC data, that will say this must current only, this must temperature only need to be measured. After that it need to be cut off, means you can
also enter these values here. Same like that, we are getting the RAC data here. So maximum you can select the language here, like as English or Hindi, and also Chinese language. So there are different types of models available in the JVD as well as DADI also. According to the MCUs, what they have used, it may be varies. That's all about the session. So, having any doubts in the BMS later, which you can ask.
The maximum voltage that we want you to
For 80. So it depends upon the cells what you are. For example, we are using 60 volt battery case, 19 cells in 19 cells in means so the normal voltage of the cell is 3.2 into 90. Now approximately you can get 60.8. So that is the for 60 volt battery you are using 19 cells. If you are using only 48 volt means you can use up to 15 cells, 15 series.
if you require 80 volts means I can increase the
You can increase the cells and if you need to increase the current, the AICTE capacity means you need to increase in the current.
for a particular module. What is the maximum voltage and maximum current? Voltage you say it's 80 volts.
Okay, sir.
What is the maximum current for that? 80 volts. What is the maximum current?
Current also there. And depending upon the load, and the torque and all that. You need to calculate the torque. Only the batteries are using in the EV side. So depending upon the how much torque the motor can be able to give us. Some others, if the motor is only up to 50 amps, like it can use 80 amps, 80 amps BMS, and also the same way the 80 amps, 80 AX capacity.
So you can have 80 volts and 80 amps in the same.
Same.
How many cells there?
Yes, sir. Parallel means on cell means you will have voltage and also capacity. So voltage means normal capacity, normal voltage is 3.6 for example, 3.6 and the capacity is depending upon the cells what you have like that. 10 AX. Okay. 10 AX means if we are connected only one parallel, that is we are connecting up to 19 series and only one parallel means 60 volt battery and 6 AH capacity. 6 amps. Up to we can load up to 6 amps.
60 volt and 6 amps.
6 amps.
19 cells.
19 series and the single cell running. So we inform that the cell that is 10 AH. Only in series means that is 10 AH. If it is in parallel means so I am just adding only in parallel. That means 1990. Total I am just having.
So you need 80 volts and 20 ampere only. So now 290.
No, sir, 60 volt only 19, sir.
Only 60 volts.
60 volt is 19. So if you need 20 AH, you need to add in another one parallel. Same thing.
90 plus 90, 38.
38. What are the other? If you need 30 AH, you need to add another one. Yeah.
So 90 cells in series with 3
3 parallel. Yeah, 3 parallel. So once we are increasing the parallel, the current will be increased. Once we are increasing the series, the voltage will be increased.
Because of the high temperature of battery center,
Into the cell, there are particles. There are two different types of cells. So once we are getting into the LFP, that will be in 48 degrees Celsius, up to 48 degrees. 48 degrees. So if you once it crosses up to somewhat it crosses up to 48 degrees, also somewhat it will happen. So it's depending upon the usage and also the depending upon the usage and also depends upon the heat also. What will happen if you don't use the VMS? What will happen is the imbalancing happens first is, and there will be a short circuit will happen. Short circuit means there will be once it is imbalancing means if you are traveling the vehicle for a long time, so there will be an imbalancing sensor are arranged. So what happens means suddenly my voltage will be in higher 68, suddenly it will drop up to 60 and 62. So like this in series combination we can get the different voltage temperature should be happen. So how the BMS works means if the temperature increases means it will turn on the fan. So it will distribute it big voltage. So without using the BMS, without using the fans, what will happen is the temperature will be increased and suddenly what happens is the cell will be damaged. So it suddenly started that's happening. So instead of without using the BMS only, those things are happening. So if you use the BMS, that will be protected. Sir, solar also only for whenever we are using the lithium, then we are using for long duration. Yes, sir. Yes, sir.
Go for solar.
Solar we are having. Sir, the first one is the solar they are using 50 degrees. So in 50 degrees, what is it? That is the voltage increase. So only with the system. So if anything happens in the connectivity unit, it will damage the battery. So that why the battery have the BMS product. It won't sense the more current and the more current also. More current and more voltage. So the BMS and battery having only able to charge up to 68 volts. So once it crosses its limit, it suddenly cut off. That is the major we are using. And current, we are also using the parameters and current also. So maximum current will be only 10 amps. After 10 amps, it is not possible to charge. Suddenly it will cut off. So for those protection, it will be like this. Yes, sir. We can analyze, for example, 19 series and so the cell number 10 is damaged, so we can listen to that will be so we are getting the information from the each cell. So from the each cell we can we can also replace the single cell and we can
Problem is suppose if there is a problem in the cell, we have to stop the
suddenly we cut off in the BMS will cut off the voltage. We don't want to give the voltage. So suddenly it will break. So you need to stop. Only thing once you are using the BMS, it will only be protection. It won't happen. I'm also doing the test to randomly, so it is not happening now. So once it happens, alternate time option is you need to suddenly you won't change. You need to change the suddenly then for example in the there is two batteries. So one is we always are using and one other one is the spare battery. So the normal EV charge you can just take the battery out and you can keep the replace the battery. So like this is the nowadays coming. So like this the real two-wheeler thing also we are having the same thing. So yes, sir. Dropping in two-wheeler but four-wheeler is that is like
Thank you, sir. On behalf of Department of Electrical and Electronics Engineering and the Organizing Committee, I extend our sincere thanks to Mr. Balamanikandan, AR, Research and Development Engineer, Power Lab Instruments Chair, for graciously accepting our invitation and being with us today, and sharing his valuable insights and expertise with us. Sir, we truly appreciate your presence and contribution. Thank you. Now, I request our beloved HOD, Dr. S. Kumar sir, to present the guest with a token of gratitude.